Hello, I'm Daniel Goldin from Merdeka118 Architects. Our practice has been using Archicad for over 2 decades and delivered numerous major projects fully designed and documented in Archicad, but perhaps the most significant one to date was Merdeka118 tower currently under construction in Kuala Lumpur, Malaysia, on completion set to become the second tallest in the world after Burj Khalifa in Dubai. I was a CAD leader of this project and want to share our experience from using Archicad to design world's second tallest tower. We worked on this project in close collaboration with local architects, structural engineers, MEP and other consultants, but in the beginning not all of them were using BIM-oriented approach. So, known as one of BIM pioneers in the industry, we were trusted by project managers with a leading role in establishing BIM coordination between project teams. And in 2016, I was invited to a big workshop in KL to share our standard BIM collaboration protocols with other consultants. So I talked in front of representatives from all companies involved about IFC, relevant softwares like Celibri doing automatic clash detection, but I think the turning point in converting all those old school consultants still living in a 2D world into embracing new BIM ways was after that workshop back in Melbourne when we started uploading our IFC models onto Aconex, which was used for this project in their model stack. And during our teleconference meetings with consultants, it became quite apparent to them how much more productive it made our discussions to have a 3D model on a screen, which everyone could easily navigate through, cut live 3D sections that can move through the model, highlight elements, look up their properties, check dimensions right in 3D. It is now becoming almost an industry standard to officially register IFC files on Aconex or other document sharing systems, but it wasn't always the case, and I think Graphisoft recognized the importance of IFC early, and as a result, Archicad has a very well-developed support for it. And another great recent improvement in Archicad was connection to Rhino, of course. But I had to pick one topic to focus on in this talk, and I thought I'd talk about GDL because in our practice we find Archicad particularly powerful because of the flexibility it provides by allowing users to create custom library parts. You can script practically anything in Archicad, and in our Merdeka118 project, the sheer scale and geometrical complexity of it pushed us. A bit like American moon landing program was a big push for science and technologies, this project forced us to put in place new GDL protocols and develop library parts we never needed before that are now widely used in a practice for other projects.
For example, a lift object reading from file storage settings. So you can simply tell it to go, say, from basement 1 to level 6, and it automatically places lift doors on corresponding levels, plus pit, overrun, motor room, and if doors need to move vertically, they can be unlocked from floor levels. And of course, the object knows what to show on floor plans, and on any floor plan, doors can be switched off if lift doesn't stop on that level or moved to the opposite side. And all these changes are reflected in 3D. So this object keeps full information about the lift, and on any floor plan you can select any lift and look up all levels it stops at, which for a 118-story tower with 33 lift shafts and 89 lifts servicing different zones makes a big difference. Or this drawing index object, preparing a list of drawings for a new issue from an external database keeping information about projects' registered drawings. It allows filtering by database fields, which will generate a list of only relevant drawings, in this case only for tender or construction. But even after filtering, when there are 4,000 drawings registered in the project, it still takes time to find from these long drop-down lists particular drawings that need to be issued. But this object can do a search by keyword and will generate a list of only those drawings containing this keyword in their names, which in the long run saves a lot of time. Or this new tool we created that can add or delete polygon endpoints and have any shape in plan. In 3D, it either keeps consistent thickness, say to model complex elevated roadworks, or underside can be controlled independently. To give some more examples, I am now navigating through one of our Merdeka118 project models. This is a corner of one of tower foyers. Say, to work out this tile breakup for walls stone cladding and then unfold elevations, we created a library path not only showing in 3D tile joints of the specified pattern, but automatically calculating and adjusting row sizes to compensate for different slopes of each stone plane in order for all horizontal joints to line up. And ideally, it helps to model everything in full detail, like this door release push button and break glass unit, so that all drawings could be generated from 3D. But then, of course, there's always a file size issue of 3D models exported to other consultants, and the speed of generating sections, elevations, which in most cases can be easily resolved by switching layers on and off, but not always. And another example of having to model in full detail would be beam smoke detectors here, because it's critical to align them precisely with reflectors on the opposite wall, which in our case governs locations of recesses and stone cladding to accommodate those devices, which in turn is a setup for tile breakup. Or we wanted to model BMU safety lines on top of our glass dome in full detail to make sure they are not going to be visible from below through the glass. And the same on the roof of glass bridge. So what we started doing from this project is we now embed a standard feature into all new library paths, an inbuilt global control. Objects will display or not display different text in plan depending on the view, or more to the point now show different level of detail in 3D. As opposed to traditional individual switches in every separate object, there is one big switch in a file controlling them all. If we look at a typical office level of the tower, at large scale, working on one level, you want to see ceiling tile breakup, supporting legs and tile breakup of the raised floor, but all general sections cut through the whole tower can be saved with this 3D detail level switch set to simple in view settings, which turns raised floors and ceilings into simple slabs, or this maintenance catwalk. Facade louvers, all our facades are modeled using a curtain wall tool, can also go into a simplified mode for large elevations, and this is different from a standard switch in model view options between full and schematic, as we still wanted them to be represented as louvers. Which brings us to a pretty big topic, the use of Archicad curtain wall tool in this project to model tower facades and podium cladding. Back in 2010, when we were contemplating possible options how to model the tower enclosure, the curtain wall tool was already available in Archicad. I think it was around since version 12, but no one in the office was actively using it yet. It was clearly obvious how impressive it was, but we were not convinced whether it was stable and reliable enough to go into documentation. But because we had more than half a kilometer tall facade to model that was going to slope in and out multiple times, intersecting, having mitered corners at various angles, we hardly had any other options. So we figured we would use curtain wall tool in schematic design and then at some point eventually replace it with some more conventional individual objects for safety and predictability. But as it turned out, we never had to do that because, again, curtain wall tool allows us to script any custom components for it. These louvers, external lighting recesses, double glazed and single glazed panels, back panels, dummy transoms, custom corner mullions, transoms that compensate facade slope to stay horizontal in section. All these custom scripted components within the curtain wall system. We are now looking at one-level cuts through large continuous curtain walls, and we can see cuts through different custom mullions and back panels. But the best thing is that Archicad accurately displays model projection in plan for slope and facades governed by current cut plane, and all components can be scripted to be scale sensitive in how much detail is shown in plan. These are those transoms that always stay horizontal in section. So it was easy for us to automatically produce fairly detailed drawings of the facade. Practically Everything you see on these images was modeled using a curtain wall tool. Not only tower facade, but also the diamond pattern cladding of podiums with lighting troughs and louvers, the 88 meters in diameter glass dome, canopies, shop fronts, and even stone entry portals. Shown here is our typical podium cladding system, and even secondary structure supporting it of concrete slabs was modeled with a curtain wall tool and specially created custom components, raking columns being mullions, horizontal purlins, transoms, and corrugated sheets panels. This way, we were able to easily modify all member sizes, spacings, and offsets centrally for the whole building envelope. We automatically scheduled podium cladding areas and numbers of panels separately quantifying transparent and spandrel, soffit and roof, and we had the same level of flexibility and control over the dome panels.
Unfortunately, the time is limited, so I can only show just a few examples of how Archicad, even though the project of this magnitude naturally presents challenges on every level, including basic tasks of modeling and documenting, still Archicad enabled our team to be creative, free from any software limitations, and to easily translate our design ideas into architectural drawings. In 2010, we started this project in Archicad 14, and though we normally have a rule of thumb in the office not to change version after the project has started, we had to make an exception for this one because, unlike most other jobs, this one's been through 10 Archicad versions from 14 to 23 now. So for us, it was a good snapshot of Archicad evolution over the past 10 years, with every new release more efficient, user-friendly, and we are now looking forward to this new and no doubt exciting chapter in Archicad history.